వెల్కమ్ బ్యాక్ టు అవర్ ఛానల్ చామకు స్పార్క్స్. సో ఇవాళ మనము ఇంటర్మీడియట్ ఫస్ట్ ఇయర్ ఫిజిక్స్ చాప్టర్ 14 ద లాస్ట్ చాప్టర్ కైనెటిక్ థియరీ ఆఫ్ గ్యాసెస్. సో మనకు అకార్డింగ్ టు బ్లూ ప్రింట్ ఈ చాప్టర్లో మనకు 2 మార్క్స్ క్వశ్చన్స్ వస్తాయి. We will be getting 2 questions of 2 marks from this chapter. So let's complete all the important and repeated questions from this chapter. Without any further, let's understand the important concepts in a simple and easy way. So the first question, state Boyle's law and Charles' law. Boyle's law. At constant temperature, the pressure of a given mass of a gas is inversely proportional to its volume. PV is equals to constant and the formula is P is inversely proportional to 1 by V. So manamu formula according we can write the definition of the law. So here at constant temperature, here we have only pressure and volume. So what must be constant temperature? So at constant temperature, the pressure of a given mass of a gas is inversely proportional to its volume. That's it. This is a small trick that you can follow. Charles' law. At constant pressure, the volume of a given mass of a gas is directly proportional to its absolute temperature. Here in the formula we don't have pressure, so at constant pressure the volume of a given mass of a gas is directly proportional to its absolute temperature. So V by T is constant and this is volume is directly proportional to absolute temperature. The next one, define mean free path. The distance traveled by a gas molecule between 2 successive collisions is known as mean free path. This is repeated most of the times, so this is also important. This is also very important. In the past previous papers this question has repeated. When does a real gas behave like an ideal gas? At low pressure and high temperature, a real gas behaves like an ideal gas. Okay. Next one, state Dalton's law of partial pressure. Dalton's law of partial pressure. At constant temperature, the total pressure of a mixture of an ideal gas is the sum of individual pressures. For n number of gases, P is equals to P1 plus P2 plus P3 plus so on. Next one, what is the expression between pressure and kinetic energy of a gas molecule? So this is the answer. What is the expression between pressure and kinetic energy of a gas molecule? So pressure P is equals to 1 by 3 mn V square, and for this ఇది pressure formula. So pressure formula కి మనము 2 by 2 మనము ఏం చేయాలంటే multiply and divide by 2 by 2 to this formula. So P is equals to 2 by 3 into 1 by 2 mn V square. Therefore, kinetic energy is equals to, what is the formula? 1 by 2 mn V square. So in the place of this, we are going to take kinetic energy. Okay. So P is equals to 2 by 3 Ke. So this is the relationship between pressure and kinetic energy of a gas molecule. Next one. Pressure of an ideal gas in a container is independent of the shape of the container. Explain. The pressure of an ideal gas in a container is given by P is equals to 1 by 3 nm V square or P is equals to 1 by 3 mn V square, which is independent of the shape of the container. So this is the one question. What is the ratio of RMS speed of oxygen and hydrogen molecules at the same temperature? So volume is inversely proportional to 1 by root m. Therefore V1 by V2 is equals to root of m1 by m2 is equals to root of MO by MH. This is oxygen and this is hydrogen is equals to, this is the hydrogen weight and this is the oxygen weight. Okay. So therefore is equals to 1 by 4. This is the ratio of RMS speed of oxygen and hydrogen molecules at the same temperature. Okay. Next one, the absolute temperature of a gas is increased 3 times. What will be the increase in RMS velocity of the gas molecules? Vrms is equals to root 3 kT by m. This is the formula. So T1 is equals to T and T2 is equals to 3T. Therefore V1 by V2 is equals to root T1 by T2. Therefore V1 by V2 is equals to root T by 3T. So here V1 is T and V2 is 3T. So therefore V2 is equals to V2 is equals to 3V root 3V RMS. Okay, so this is the solution. This is another one. 4 molecules of gas have speeds 1, 2, 3 and 4 km per second. Find the RMS speed of the gas molecules. VRMS is equals to, this is formula, root of V1 square plus V2 square plus V3 square plus V4 square by 4. So therefore 1 square plus 2 square plus 3 square plus 4 square by 4 is equals to, we will be getting, so as you can see, we will be getting root 1 plus 4 plus 9 plus 16 root by 4. Therefore, root 30 by 4 is equals to root 7.5. Therefore, that is 2.7 km per second. Next question. When pressure increases by 2%, what is the percentage decrease in the volume of a gas, assuming Boyle's law is obeyed? According to Boyle's law, P is inversely proportional to 1 by V. That is delta V by V into 100 is equals to delta P into 100. That is change in pressure by pressure into 100. So change in volume by volume is equals to minus 2%. So volume of a gas decreased by 2% when pressure is increased by 2%. So guys, finally we have completed the intermediate first year physics syllabus. So please check out for the other chapter videos in our channel. Don't forget to like, share and subscribe to our channel Chamko Sparks. We will be uploading the chemistry syllabus soon.